Welcome to Engenius Films, sharing the genius of engineering.
I'm going to meet some more engineers, but they're not in an engineering department or a production plant, they're in a medical school.
I went in for a heart-to-heart with Claudia, Ivona and Andrew, who all work in the field of biomedical engineering.
A biomedical engineer is an engineer that focuses research or interest on the human body or anything that can be used in a hospital.
I am working on the heart and I am focused on the coronary arteries, which are supplying the blood to the heart. The interesting fact is that our heart beats 30 million times a year. In 1 minute, a heart delivers 5 liters of blood to our body.
The coronary arteries, which we're interested in, their job is to provide the blood to the heart itself.
The coronary arteries can be blocked with the cholesterol and the fat and the proteins. It is a problem because the blood cannot be supplied to the heart and it can cause the heart attack.
One of the options for sorting out a blockage was to open the patient's chest and to put a bypass vessel into the heart. That's effective, but it's quite a big procedure. A new technique is to put what's called a stent into the artery, and this can be done without opening the chest.
A stent is a sort of scaffold that is implanted in the vessel.
It's an implant which expands in the vessel wall, keeping the vessel wall open so the blood can flow to the heart again.
A stent is a kind of a cylindrical mesh made of metal or polymers.
The choice of the material for the stent is important because it needs to be strong enough that the stent remains open to keep the artery open, but it needs to provide enough flexibility that the stent can move as the heart pumps.
It has just really tiny diameter, like from 1 millimeter diameter going to 3, 5 when it's expanded.
The stent is placed in the artery by making a small cut in the artery in the leg and then feeding the stent all the way up through the blood vessels until it reaches the vessel that supplies the heart. The stent is placed inside the patient using a balloon, and the balloon is inflated using a pump. To improve stent design, we do research in a couple of areas. One of those is experimental measurement, and the other area is computational simulation.
In the experimental work, I am expanding the stent, which is crimped on the balloon, and I am observing with 2 cameras how the stent is behaving during the expansion.
My work is to study the interaction between the stent and the vessel through computational models.
To create a computer model of the stent, the information that we need is the structure of the stent, what it looks like, and the material that the stent is made out of.
The reason why I have this representation is to understand what can go wrong when a stent is put in the vessel. It can have big forces on the vessel, and I want to study if these forces can be dangerous for the vessel.
Computer models are really effective. What they allow us to do is to look at lots of different possibilities in the computer before we build something physically.
The idea of this research is to understand how to improve the design of the stent.
If there are some parts of the stent that stick out too much, they can penetrate into the vessel and create a bigger damage.
The benefit for the patients with improved stent design or any type of medical device design is that they're likely to need less treatments in the long run.
Good prevention to heart problems is a good diet and sport. When I'm not in front of my computer working, I like to go outdoors and particularly climbing.
I like to ride my motorbike, and additional thing which I like to do is playing ukulele.